Is this really better than this? Today we will answer one of the most common questions in astronomy, which is what can be observed with telescopes of different sizes. Let's compare a small 60mm refractor telescope, a 150mm Maksutov-Cassegrain catadioptric telescope, and a 250mm Newtonian reflector. In addition, we will make some references to what you can see through a beast like this. My name is Miguel Azorín, and I welcome you once again to Natural Portraits. If you're thinking about buying a telescope or are just curious, this video is for you. Throughout this video, we will analyze what we can expect from each size of telescope, observing some of the most common things we usually point our equipment at in the sky. And probably the first object that we all point a telescope at is the moon. With a small 60mm telescope, we can already start seeing a lot of details on the moon. However, we will be surprised, especially by the ability to clearly identify the largest craters. Craters like Tycho, Copernicus, or Clavius. However, we will probably miss the smaller details. Still, it's perfect for starting to explore our satellite. A 150mm telescope like this Maksutov-Cassegrain will allow us to see the craters and lunar mountains with much more clarity. We will also see details in the lunar seas, like small cracks and chains of craters. And with a 250mm Newtonian telescope, that's when we'll really see our satellite come to life. With this aperture, we will start to distinguish the finer details of the walls of the craters. And we will start to observe complex structures, like the central peaks of some craters. In addition, the moon is an excellent target for practicing astrophotography. With any telescope and an adapter for your camera or smartphone, you can capture stunning images of its surface. But if you decide to use a specific camera for planetary astrophotography along with a motorized mount, that's when the captured details really become spectacular. I remind you that within the Natural Academy by TRIZ, you can find the Planetary Astrophotography course, where I explain all the techniques to achieve this type of photography, both of the moon and the planets and the sun. Now let's move on to talk about what we can expect to observe on the planets of the solar system with these three telescopes. With a small 60mm telescope, when looking at gas giants like Jupiter or Saturn, we can start, for example, with Jupiter, to appreciate its main bands and the 4 Galilean moons as bright dots around it. In the case of Saturn, we will start to clearly differentiate how the ring and the planet's disk are separated, although we won't be able to appreciate many more details. On rocky planets like Venus or Mars, we will be able to clearly see the phases of Venus without any problem. And Mars will become a small challenge where we can identify its reddish disk and one of its polar caps, under good stable sky conditions. With a 150mm telescope, the planets come to life much more. On Jupiter, we will be able to clearly identify the bands and belts of the planet, and under good atmospheric stability conditions, we will clearly see the Great Red Spot, the largest storm in the solar system. On Saturn, we will start to appreciate some of the planet's faint bands, and the most striking thing will be that we can see how the ring is divided into two by a dark line called the Cassini division. The rocky planets start to gain prominence with this aperture. Venus, which is the closest planet to Earth, will appear huge when its position gets closer to us. And Mars will now clearly show its polar cap and some dark details on its surface. A 250mm telescope or larger allows us to have a clear, high-resolution view in planetary astronomy. With these apertures, the planets already appear brighter and full of details. It's important to get our eyes used to it, take advantage of good atmospheric stability, and we will see how each time we are able to observe finer and finer details, like small swirls and festoons on Jupiter. And even the Encke division in Saturn's rings, a thin gap found in the outermost part of the ring system. The rocky planets now allow us to observe all sorts of details, especially Mars, a planet that, as we've said, can be a challenge with small telescopes, but with larger telescopes, it can be very rewarding. Remember that atmospheric stability plays a crucial role in planetary observation. It's not all about the size and quality of the instrument. The stability of the sky is one of the most important aspects. Deep sky is probably one of the aspects that most interests amateur astronomers. Although it has its complexity, and that's why we've left it for last, let's make a comparison of what we could expect. Observe with these three types of telescopes on three of the most famous objects in the night sky: the Orion Nebula, the Pleiades, and the Great Andromeda Galaxy. It's important to be clear that with none of these telescopes will you be able to see colors with your own eyes through a telescope. In this other video, I tell you why. And in a moment, I'll tell you how you can actually see colors with your own eyes through a telescope. With a 60mm telescope on the Orion Nebula, we'll see a faint elongated glow. And with a bit of luck, we'll clearly see the trapezium, a group of newly born stars that are very close together at its center and provide all the brightness, or the great amount of brightness that this nebula has. The case of the Pleiades is different. It's an open cluster of very bright stars, which is perfect. For observation with a telescope of this kind, we'll be able to see the entire cluster in its entirety. The Andromeda Galaxy is also visible with a telescope of this kind, although we will see it as a large, elongated patch in dark skies. With a 150mm telescope in the Orion Nebula, we'll start to see the edges of the nebula appearing, and overall we'll have a more contrasted image between bright areas and dark areas. In the case of the Pleiades, we will see the stars gain brightness under very dark skies. We could even sense the bluish glow of the nebula that surrounds them. In the case of the Andromeda Galaxy, we'll clearly see its elliptical shape, and we'll start to detect its bright core. With a 250mm Newtonian telescope, we'll start to see in the Orion Nebula intricate structures and details in the gas and dust regions. It's truly a gem to observe through large telescopes. In the Pleiades, we will see the nebula that surrounds this cluster of stars much more prominently, and the stars will appear like true pinpricks. In the case of the Andromeda Galaxy, we will begin to detect details in its spiral arms, and we will see how its galactic satellites, the galaxies M32 and M110, now, they are visible. For deep sky objects, make sure you're under the darkest sky possible, and use low-power eyepieces to capture more field of view and more light. Certain filters, like the UHC ultra-high contrast, can also enhance contrast and help see certain nebulae more clearly. A moment ago I told you, yes, there is a way to see colors directly with our eyes through a telescope, and it's by observing through very large telescopes. At Natural Portraits, we organize the Calar Alto Experience annually, a weekend where we learn astronomy and astrophotography, alongside other enthusiasts, like us. At the Calar Alto Astronomical Observatory in Almeria, one of the leading astronomical observatories in Europe, together with the Azimuth Spain team, we also enjoyed an astronomical observation session through the 1.23-meter telescope at this observatory, the largest telescope in Europe, ready to operate with an eyepiece. And yes, with a diameter of 1.23 meters, we can indeed see colors with our eyes. If you also want to enjoy the Calar Alto experience, visit the link you'll find in the first comment and in the description of this video. Are you thinking about buying a telescope, and would you like to learn how to use it? I remind you that at Natural Portraits Academy, we can help you with that. You'll find training in planetary astrophotography, also deep sky astrophotography. Master the technique for photographing nebulae, galaxies, or star clusters. And you will also be able to dive deep into the world of night photography, in addition to other branches of natural photography like macro and extreme macro photography. You'll find courses ranging from beginner to advanced level. And remember that all the courses are paid, lifetime. Access, they receive regular updates and have a direct email consulting service with me. I hope this video has helped you understand what you can expect from the different sizes of telescopes. The bigger the better. The decision is yours. Don't forget to subscribe, leave a like, and activate the bell for more content. Clear skies, and see you next time.